Hi, friends and friends. This is your host and teacher, Sayyid Ayazuddin Haider, and you're watching Learn and Teach by Sir Ayaz. So, in this video lesson, I will talk about past paper questions related to the topic periodic table. So, here's question number one. Group 1 includes the elements lithium, sodium, and potassium. A. State two physical properties of lithium. This is 2 marks question. You have to state any two physical properties of lithium. Part B. Potassium reacts with cold water. The ionic equation for the reaction is shown. 2Ks plus 2H2L gives 2K plus aqueous plus 2OH negative aqueous plus H2 gas. Describe what is observed during this reaction. Now, this question is of 2 marks also. So you have to write at least give three observations. Here's the position of lithium in the periodic table. By looking at the position of lithium in the periodic table, it's a group 1 metal. You can easily predict any two physical properties like it is soft, it has low melting point, low boiling point, low density, malleable, ductile, thermal conductor, electrical conductor, floats on water. So you can write any two of these physical properties. For the next part, that is part B, in which they are asking about the observation of potassium when it's reacted with cold water. So you can write any three of these observations, and this include the potassium metal, it floats on water, or potassium floats on water, or you can write moves across the surface of water. Potassium melts. You can write bubbles, fizzes, effervescence. It forms a colorless solution. And last one, which is the typical color of potassium, that is lilac flame. Question number 2. Group 7 includes the elements fluorine, chlorine, bromine, and iodine. Part A. Chlorine is a green gas at room temperature and pressure. State the appearance of iodine at room temperature and pressure. Now, this is something which you have to learn by heart. So the color of iodine at room temperature pressure is gray-black, and it exists in the solid state. This question is of 2 marks. Part B. Chlorine reacts with aqueous potassium iodide in a displacement reaction. 2I minus aqueous plus Cl2 aqueous gives 2Cl minus aqueous plus I2 gas. Describe what is observed during the displacement reaction. Now, this is a displacement reaction between highly reactive halogen with the compound of less reactive halogen, in this case, iodine. So initially, the solution is colorless and it turns to orange or brown due to the formation of I2. Moving to next question, that's question number 3. Fluorine, chlorine, and bromine are in group 7 of the periodic table. Part A, state the name given to group 7 elements. Part B, explain why group 7 elements have similar chemical properties. Both of these questions are of 1 mark. Part C, chlorine displaces bromine from aqueous potassium bromide, but does not displace fluorine from aqueous sodium fluoride. Part 1, write the symbol equation for the reaction between chlorine and aqueous potassium bromide. This is of 2 marks. Part 2, state why chlorine does not displace fluorine from aqueous sodium fluoride. Now look at this periodic table. Here's the position of halogens in the periodic table. It's a group 7 metal. You can see here. And there are 7 outermost electrons. That's why they all have similar chemical properties. The other thing is that in this group, as you move down the group, that's from fluorine, chlorine, bromine, iodine, astatine, and tennessine, the reactivity decreases. This is a trend. Coming back to the question, this is a question which they have asked. They are asking the name of the group 7 elements. They are known as halogens. In part B, they ask, explain why group 7 elements have similar chemical properties. Simply, you have to write same number of outer shell electrons. Next question of question number 3, that's part C. Chlorine displaces bromine from aqueous potassium bromide, but does not displace fluorine from aqueous sodium fluoride. In part 1, they are asking to write the symbol equation for the reaction between chlorine and aqueous potassium bromide. So you write 2K-Br aqueous plus Cl2 aqueous gives 2KCl aqueous plus Br2 aqueous. Number 2, state why chlorine does not displace fluorine from aqueous sodium fluoride. As I've already mentioned that it's below. Reactivity decreases down the group. So chlorine is less reactive than fluorine. Now question number 4, this question is about metals. Part A, chromium is a transition element. Sodium is an element in group 1 of the periodic table. State 2 physical properties of chromium that are different to those of sodium. Now you have to write 2 properties of chromium which are different to those of sodium. So 2 marks. Part B, chromium 3 oxide Cr2O3 reacts with carbon and chlorine to produce chromium 3 chloride CrCl3 and carbon monoxide. Construct the symbol equation for this reaction. If you look at the position of sodium and chromium in the periodic table, you can see sodium is in group 1 and chromium is among transition elements. So you can easily differentiate the physical properties between these two. For example, group 1 metals, they are soft, they have low melting point, low density. These are the typical differences between group 1 and transition metals. For transition metals, you can write the reverse statement. Like transition elements, here it's chromium. They're hard, they have high melting point, they have high density. So you can write any 2 of these physical properties for sodium and chromium. Here's a question. Now for the answer, I have already explained you the answer. You can write any 2 of these statements, any 2 physical properties of chromium that are different to those of sodium. So higher density, sodium has lower density, higher melting point, that is for chromium. Sodium has lower melting point, hard, that's for chromium. Sodium is soft. Part B, chromium 3 oxide Cr2O3 reacts with carbon and fluorine to produce chromium 3 chloride Cl3 and carbon monoxide. Construct the symbol equation for this reaction. So you write Cr2O3, they have mentioned. Symbol of carbon is C and Cl2 is chlorine. Cl2 for chlorine, and for chromium 3 chloride, you will write CrCl3. That's the product produced in this. Question number 5, the reactivity of group 7 elements can be investigated experimentally. A student bubbles chlorine gas into a test tube containing aqueous potassium bromide. Number 1, describe the color change seen in the test tube. So this is a reaction between chlorine gas and potassium bromide. Simply the color will change from colorless to orange due to the formation of bromine. Number 2, complete the ionic equation for this reaction. Include state symbols. So here's dash plus Br minus aqueous gives dash plus dash. So you write Cl2 gas plus 2Br minus aqueous gives Br2 aqueous plus 2Cl minus aqueous. Number 3, the reactivity trend seen in Cl, Br, and I applies to all the elements in group 7. Use the periodic table to identify the group 7 element which cannot displace any other group 7 elements. So group 7 elements, we have fluorine, chlorine, bromine, iodine, astatine, and tennessine. This is the last element in this group. You can see here, its symbol is Ts, and the reactivity decreases down the group. So TS or tennessine is the right answer for this question. So that's all for this video. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.